welcome to the next tutorial class, that is lecture 6 tutorial 1. So, this is on the topic that is on the scattering matrix. So, here is the next problem. Derive the scattering matrix for each of the lossless transmission line shown below. So, here it is two transmission line is shown. So, first transmission line has this characteristics impedance of Z naught and second transmission line has characteristics impedance 2 Z naught relative to the system impedance of Z naught. So, here means we have to assume that port 1 and port 2, when we are measuring this measuring some S parameter for this port 1 means for the first configuration and for the second configuration, that means transmission lines. Here we are assuming port 1 is connected with Z naught and port 2 is connected with Z naught. Verify that each matrix is unitary. So, first we will go to the first problem that has characteristics impedance Z naught. So, we can go to the first one. So, we can also see that here the length of the transmission line is L. So, for the first part, so this is the Z naught, port 1, port 2 and length of this is L. So, S11, now we know S11 is defined as V1 minus divided with V1 plus when V2 plus equal to 0. V2 plus equal to 0, that means we have to terminate the port 2 with Z naught. That means here it is port 2, if it is port 2 and we are terminating this with Z naught. V2 plus means equal to 0, that means no reflected, means reflected from the load, that means V2 plus equal to 0. There will be no reflected wave from load. So, V2 plus equal to 0 and port 2 is terminated with ZL is equal to Z naught. So, since the transmission line has also characteristics impedance Z naught, there will be no reflection and so this transmission line will be matched with this load impedance Z naught and there will be no reflection, and as a result we will get V1 minus equal to also 0. So, because this and V1 minus equal to 0, that means there will be no reflected wave from port 1. There will be no reflected wave means port 1. So, port 1, because this is Z naught and here we have also connected with Z naught. So, that means there will be no reflected wave and we will get V1 minus equal to 0. That means V1 minus equal to 0, that means V1 S11 equal to 0. So, for this S11 equal to 0. Similarly, for S22, if port 1 will be terminated with, so we can see the definition of S22. S22 is defined as V2 minus divided with V2 plus when V1 plus equal to 0. V1 plus equal to 0, that means port 1 is terminated with Z naught and there will be no reflection from port 1 and V1 plus equal to 0. Since there is no reflection from port 1 and this characteristics impedance of the transmission line is also Z naught, in that means V2 minus equal to 0. that means V2 minus equal to 0. There will be no reflected wave from port 2. V2 minus equal to 0, that means S22 equal to 0. And so, here we got the S11 equal to 0, S22 equal to 0. Now, to find out the S12 and S21, for S12 we can write V1 minus divided with V2 plus when V1 plus equal to 0. So, V1 plus equal to 0, that means this port 1 is terminated with match load, and V2 minus is V2 minus. So, V2 minus, so V2 minus, this first is V1 minus is this one, and V2 plus is this one, right. This is V2 plus. So, waves are entering at port 2 and leaving at port 1. That means, it is like a S12 is like a transmission coefficient when wave is entering from port 2 and leaving at port 1. So, this will, and we know there is this length of the transmission line is L. So, this will be equal to V2 plus, that means S12 there, because this is lossless, right, it was written, right, lossless transmission line. So, for this case S12 equal to e to the power minus of j beta L. So, waves are entering from port 2 and leaving at port 1, and beta L is the phase change between this length L. Similarly, for S21 equal to V2 minus divided with V1 plus, when V2 plus equal to 0. V2 plus equal to 0, that means port 2 is terminated with match load, and now in this case V2 minus, waves are means leaving from port 2 and entering at port 1, that means like this. V1 plus is here, and V2 minus, that is leaving from port 2. So, S21 is like a transmission coefficient from port 1 to 2, V2 minus. So, again this will equal to e to the power minus of j beta L. So, we have got means S11 equal to S22 equal to 0, and S12 equal to S21 equal to e to the power minus j beta L. A scattering matrix can be written as a scattering matrix can be written as 0 e to the power minus j beta L e to the power minus of j beta L 0. So, this will be the scattering matrix for the first configuration. After this, we can go to the second configuration. In the second configuration, everything is same, just characteristics impedance of the line is replaced with Z0 is replaced with 2 Z0. It is 2 Z0, and everything is length is will be L, it will be same, and here this side is port 1, port 2. So, for this case we can see that means if we will terminate the port 2 with Z naught, in this case we will not get the means V 2 plus will not equal to 0, because this is a this characteristics impedance is 2 Z naught. So, for this problem we have to attempt in some different way. So, first we have to find out means S11 equal to V1 minus divided with V1 plus when V2 plus equal to 0, that is gamma in. We can denote this like a gamma in, because this is a symmetrical, then we can also write this will equal to S22, but this will come later. So, we will do all the calculation for the S11 and in the last we will equate S11 equal to S22. We can denote like this. So, if here it is gamma in, we can see here it is gamma in, and we can denote here gamma 0. We can denote this is gamma 0 at port 2 and gamma in at port 1. So, gamma in equal to S11. Gamma 0 we can calculate V 2 plus equal to 0, again V 2 plus equal to 0, that means there is no reflected wave coming from load, that is Z naught. So, if it will be Z naught, so there will be no reflection from that side, from the port 2 load side. In that case V 2 plus will equal to 0 and V 2 plus equal to 0, for that case we can find out gamma 0, we can find out gamma 0 as ZL minus Z naught divided with ZL plus Z naught. ZL will be Z naught. So, we can write ZL minus Z naught, ZL plus Z naught. So, for this configuration this side is 2 Z naught and we are terminating port 2 with Z naught. So, here ZL will be Z naught minus Z naught, but this is the original formula, this is original formula. So, here ZL will be Z naught and Z naught will be 2 Z naught, Z naught will be 2 Z naught divided with ZL will be Z naught plus Z naught will be 2 Z naught. So, because Z naught is the characteristics impedance of some line, but here characteristics impedance is 2 Z naught, that is why Z naught is replaced with 2 Z naught. So, after solving this will come minus Z naught divided with 3 Z naught minus Z naught divided with 3 Z naught equal to minus 1 by 3. So, gamma 0 will be minus 1 by 3, and for gamma in we know the formula for the gamma in terms of length L. So, that formula is gamma in equal to, so that is Z naught 1 plus gamma 1 plus gamma. So, this is the general formula minus of J 2 beta L divided with 1 minus gamma e to the power minus 2 J beta L. So, this is the formula for the gamma in. So, this gamma is the gamma 0, this is gamma is the gamma 0, and if someone will substitute gamma equal to ZL minus Z naught divided with ZL plus Z naught, we will get the same famous formula Z naught ZL plus J Z naught tan beta L divided with Z naught plus J Z L tan beta L. So, this will give when gamma will be replaced with ZL minus Z naught divided with ZL plus Z naught, and after that means I have to solve in terms of sin and cos, like cos beta L e to the power j beta L plus e to the power minus j beta L by 2, like that for the sin beta L. Then after that I have to solve and will get this formula, but we can work from this formula only. So, gamma in we can go through this formula, and gamma in equal to Z naught. Z naught in our case, that is 2 Z naught. So, we can write 2 Z naught 1 plus gamma 0 e to the power minus 2 j beta L divided with 1 minus gamma 0 e to the power minus 2 j beta L. So, gamma is gamma 0 and Z naught is 2 Z naught of the, that is characteristic impedance of the transmission line. So, we are substituting gamma 0 equal to minus 1 by 3. So, after substituting we will get 2 Z naught 1 minus 1 by 3 e to the power minus 2 j beta L divided with 1 plus 1 by 3 e to the power minus 2 j beta L. So, this will come gamma in, and Z in, this will come Z in. We are finding out first Z in. So, this is Z in, and from this Z in we can find out from this Z in we can find out gamma in. Gamma in will be we are seeing from this port, So, gamma in will be Z in minus Z naught divided with Z in plus Z naught. Now, we can substitute the Z in value from here, and after substituting we will get. So, Z in can substitute 2 Z naught, Z naught will cancel out, right. Z naught will cancel out, and in the first part it will come 2 1 minus 1 by 3 e to the power minus 2 j beta L, and in denominator part will go this side, and this will minus it will come 1 plus 1 by 3 e to the power minus 2 j beta L divided with 2 into, for this part Z in plus Z naught, 2 into 1 minus 1 by 3 e to the power minus 2 j beta L plus 1 plus 1 by 3 e to the power minus 2 j beta L. So, this will come, and after solving this we will get the gamma in, and that will equal to 1 minus e to the power minus 2 j beta L divided with 3 minus 1 by 3 e to the power minus 2 j beta L. So, this is the gamma in, and we know gamma in. So, this will equal to S11 equal to S22, because this is symmetrical, and gamma in we are seeing the impedance, this reflection from port 1, and for S21 and S12 we have to do some calculation again. Now, we have to find out S21 and S12. So, let us find out. So, we have the transmission line like this. So, this side we can assume it is given that this side is Z naught, and this port 1 side this is also Z naught, and here this side is 2 Z naught, and here we can assume that this is Z is equal to 0 and this is equal to Z is equal to minus L. This is at Z is equal to minus L, and we are finding out here it is gamma 0, here it is gamma 0, and here it is gamma in, here it is gamma in, and it is at Z is equal to 0 and Z is equal to minus L. So, V 1 plus will be V 1 plus and V 1 minus, this reflected from port 1, V 1 minus, this side is port 1, and here port 1 means here it is port 1, and here is port 2, V 2, then V 2 plus, and we are terminating with Z naught. So, there will be no reflection from this, that means V 2 plus this, and this will equal to 0, and V 2 minus. So, we are finding out for this S21 equal to V 2 minus divided with V 1 plus when V 2 plus equal to 0. That is why we have taken this condition V 2 plus equal to 0. So, here S21 is defined as V 2 minus divided with V 1 plus. So, but at port 1 we can define like V 1 equal to V 1 plus V 1 minus equal to, and at port 1 their reflection is gamma in. So, we can write V 1 minus equal to gamma in into V 1 plus, and we can take the common V 1 plus 1 plus here 1 plus gamma in, and for any transmission line if voltage on this is V plus and voltage on this side is V minus. So, in terms of L we can find out, we can write the V 1 as V 1 means at Z is equal to minus L, we can write as V plus at Z is equal to minus L. That is why it is e to the power j beta L minus 1 by 3, because their reflection is minus 1 by 3 Z naught and 2 Z naught, V plus e to the power minus j beta L. This is the total voltage at port 1 in terms of L. Similarly, for the port 2, that is at Z is equal to 0, V 2 equal to, we can write V 2 plus V 2 minus equal to, and V 2 plus equal to 0, because we are finding out this S21. So, this will be V 2 minus equal to V plus at Z is equal to 0, V plus 1 minus 1 by 3 at Z is equal to 0. So, from this expression we will get V 2 minus equal to 2 by 3 V plus, and V plus from the first equation V plus we can write, we can take the common, and V plus we can write V 1 plus 1 plus gamma n divided with e to the power j beta L minus 1 by 3 into e to the power minus j beta L. So, we can write 2 by 3 2 by 3 V1 plus 1 plus gamma in divided with e to the power j beta l minus 1 by 3 e to the power minus e to the power j beta l. So, this is V 2 minus, and so this is in the bracket, it is not mod. So, 1 plus gamma in. So, gamma in value we can substitute. So, we have gamma in value we can substitute. This will be the gamma in 1 minus this one, 1 minus e to the power minus 2 j beta l divided with 3 minus 1 by 3 e to the power minus 2 j beta l. So, gamma in will be same. So, we can substitute, we can write like this, V 2 minus equal to 2 by 3 2 by 3 V 2 minus, and we can make out this V 1 plus this side, it is in the below 2 by 3 1 plus 1 minus e to the power minus 2 j beta l divided with 3 minus 1 by 3 e to the power minus 2 j beta l. We are substituting the gamma in value divided with e to the power j beta l minus 1 by 3 e to the power minus j beta l. So, it is same, e to the power j beta l minus 1 by 3 e to the power minus j beta l. So, after solving this we will get, so it can be solved. So, this will come 8 by 3 e to the power minus j beta l divided with 3 minus 1 by 3 e to the power minus 2 j beta l. So, this is V 2 minus divided with V 1 plus, that will equal to S 1 2. So, this is equal to, this is S 2 1, this is S 2 1, because this is the symmetrical. So, this will equal to S 1 2 equal to S 2 1, this S 2 1, and this will equal to S 1 2 also. Now, in the question we can see, to satisfy the unitary condition, so have to verify the each matrix it is unitary or not. So, to satisfy the unitary condition, so in the first part it was already unitary, right, that was means in the first part. So, everything is in the imaginary. So, here it will summation of this plus summation of the second part, this will equal to 1. So, this satisfies the unitary condition. In the next part, that means it is a lossless. In the next part, for this part we have to check this, we have to also satisfy S 1 1, S 1 1 whole square plus S 2 1 whole square. So, equal to 1 minus e to the power minus 2 j beta l divided with 3 minus 1 by 3 e to the power minus 2 j beta l whole square plus, that will come 64 by 9 into 1 divided with 3 minus 1 by 3 e to the power minus. So, we are just substituting the above value whole square. So, here it is mod. mod of S11 whole square plus mod of S21 whole square. So, it is coming in this format. After this in the denominator part both are same. So, we can write this expression as 1 minus e to the power minus 2 j beta L whole square plus 64 by 9 divided with 3 minus 1 by 3 to the power minus 2 j beta L whole square, and because this is in the mod, so this can be written as 1 minus e to the power minus 2 j beta L into 1 minus e to the power 2 j beta L, because mod we have to remove the mod. So, a mod of a whole square equal to a into a star into where a star e to the power minus 2 j beta L, here it is plus 64 by 9 divided with 3 minus 1 by 3 to the power minus 2 j beta L, and for this case also 3 minus 1 by 3 to the power 2 j beta L. So, after this have to multiply this, and it will come 1 minus e to the power minus 2 j beta L minus e to the power minus plus 2 j beta L plus 1 plus 64 by 9 divided with 9 minus e to the power 2 j beta L minus e to the power minus 2 j beta L plus 1 by 9. So, 9 plus 1 by 9 and 1 this 2 plus 64 by 9, this will come, and after this will be equal, and this part. So, this part will be equal to 1. So, now we can see that say that this is unitary. So, this problem is solved now. Thank you.